Well, welcome to another video here, BC Calculus students. We're going to look today at how to score the 2014 free response questions, questions 1 through 3. So you should be watching this after you've finished doing these 3 questions. And so let's go ahead, let's take a look. So first we are calculator active, and this is a question that works for both BC and AB content. So we have our famous grass clippings one. This is one that's pretty well known. And so let's look at how it should be scored. So first for A, we want the average rate of change on the interval 0 to 30. So average rate of change is that slope that's determined by looking at the values at the beginning and at the end. So we know that since we have our amount formulas, so we look at the average rate of change. We have A of 30 minus A of 0 over 30 minus 0. We must see this fraction here. Just the answer will not do it. And we must see units in pounds per day. So we must see a fraction. Now you can have the actual numbers in here, but we must see the fraction set up. We've got to see the setup to get that point there. Just this will not get you the answer, not get you the point. Okay, then for B, so if you find the correct derivative of A at 15, which is that negative 0.164, or if you truncate negative 0.163, that gets you a point. Now your interpretation, this is where you have to use English carefully. Okay, it is the amount of grass clippings in the bin is decreasing at a rate of that many 0.164 pounds per day at the time of 15 days. So all of that must be included. I believe that with the interpretation, you do have to use the correct units, and you do have to have the idea that the amount, now you have to be careful because it's not that the rate that the grass clippings is decreasing, it's the amount of grass clippings is, so you have to be careful on that. So it's the amount that is decreasing at that given rate. All right, so let's look at part C. Part C is worth 2 points. So first, if you get 1 point if you set up the integral correctly, which means that you must have the 1 over 30 to do the average value. You must have the correct limits of integration, 0 to 30, and you must have the correct amount function there. So all of that is required to get that 1 point. Then if you actually know how to enter that correctly in your calculator and you come up with the correct answer, then you get the 2nd point. That one's pretty straightforward. You must have the integral expression. A bald answer here gets you nothing. Just the answer gets you nothing. You got to have this to get this. Okay. Then for part D, so 2 points for this correct expression for L of t. So you have to know that it's the amount, the initial amount, or sorry, the ending amount, plus, and now we're going to do, here's our tangent line approximation. Okay, that's our y1 essentially there. This is our rate, our slope, our derivative at that point. And we don't know what the derivative is beyond that, but we just get the derivative at that point, and we have our t minus 30. And so using that to approximate, if we get the correct, if you get the correct expression here for L of t being 0.5, so if you do that, if you set it equal to 5, so if you get this expression here, you get 2 points. If you set the expression equal to 0.5, then you get another 1 point. And then if you actually evaluate it correctly and solve for the correct time of 35.054, you get your 4th point. Okay, so that's 4 points there for that. Score it out of 9, and let's move on to number 2. Number 2, right away we see we've got polar. So we're looking at a polar one this time. You're using your calculator. Once again, we are calculator active. So let's look at how to score this one. So first, for part A, we want to find the area of the region R, which is the shaded region that we have here. And they even help us out by telling us It's the region that's inside this graph, r equal to 3. By the way, that's this circle here, or this half circle. And inside the graph of this 3 minus 2 sine of 2 theta. And that's kind of this peanut-shaped region here, partial peanut-shaped region. So we are just looking for that graph. So essentially what we are going to do here to find this area is we must find the area of this peanut region going from theta of 0 to a theta of pi over 2. And then we will find the region inside this circle going from pi over 2 to pi. Now we can, on this one here, we can integrate to find that one, or we can just simply know that it is a quarter of a circle with radius 3 and go ahead and use geometry for that part. That would be okay. So here's what we get. We've got our area is going to be, and what they did, what we see here is that this is just this 9 pi over 4. That comes from just the geometry of the region. So they assumed that you'd got the region, that one from geometry. And then now here's the formula here for this peanut-shaped region. So it's our r, that's our r right there, squared times 1/2. The 1/2 can be inside, that's fine. And so if you get the correct 3 minus 2 sine 2 theta squared, don't worry about limits or anything like that. If you have that correct thing there squared, it's got to be the squared on the outside of that, you get 1 point. If you get the correct limits, 0 to pi over 2, you get your next point. Your answer comes from all the rest of it, knowing you can get that from the quarter circle and knowing you have your 1/2 there, your factor of 1/2 leading to the correct answer. Okay, part B. Part B, if you correctly look at the expression for x, remember x is equal to r cosine theta. So there's your r times your cosine of theta. So if you have that correct expression, you get a point. And then if you actually evaluate it correctly to get that answer, you get another point. For part C, if you have the correct expression for distance, so our distance is 3, that's our radius, minus our r, which is right here. And so we see that's equal to 2 sine of 2 theta. This right here gets you the point for the expression, so long as you don't incorrectly simplify. And then if you do it correctly to find your answer of -2, you get your second point. Finally, 2 points for part D. First, you get 1 point for your correct chain rule. In other words, your correct implicit differentiation here. So your dr dt, when you take a derivative with respect to t, you get this expression here, which is 3 times dr d theta. So if you do that correct chain rule, then you get your, you end up with 1 point, and then if you get the correct answer out of -6, you get the second point. Okay, score that one out of 9, and let's move on to question 3. Okay, question 3. Now this one is a little bit different because we don't have a graph of a derivative, we have a graph of f, but we're going to do the same thing that we normally do with it, because they're going to talk about a function g that is the integral of this function. So a lot of times they give us a graph of f prime and then they ask us about f. In this case, they define g to be the integral here, so we'll look at this. So the first thing we want to do is find g of 3. So in other words, we're finding the integral here of from -3 to 3 of f of t dt. So we have to use going from -3 right here to 3 right here, we have to use geometry. And so doing that, if we set it up correctly and get 9, you get credit. Now, if all you have is, you've got to have the integral expression there. If all you have is just 6 plus 4 minus 1, it's not going to get it to you. You can leave off the 9. You could leave your answer as this, but you have to have some form of integral expression in your setup. Then for part B, so you get 1 point for your answer, and your answer are these correct intervals, -5 to -3 and 0 to 2. And the other point is for your reasoning. Somewhere you have to link that the derivative of g is equal to f of x, and then you have to indicate that g is increasing and concave down on those, because those are the regions where the function of f is decreasing and where the function of f is, increasing and concave down. So that's where f is positive and where f is decreasing. So you got to have that for your reasoning there. Okay, C, 3 points. 2 points is for the correct derivative here. So we need to see that correct derivative, which is the chain rule in action. Sorry, I said chain rule. It's the quotient rule in action. So if you get that correct derivative, you get 2 points. So we have this right here. And then if you actually plug in correctly and evaluate correctly, now you can leave it like this, but whatever you leave it as has to simplify to -1/3. If you do simplify down, you do have to simplify it down correctly to get the answer point. And then finally for D, you get 2 points for getting the correct derivative for P at X. This requires chain rule in action right here. So we need to see that f prime of x squared minus x times the 2x minus 1. And then if you evaluate correctly and get 6, you get your other point. Okay, score that out of 9 and then score the whole thing out of 27. Take a picture and turn it on in. And we will have a Zoom session tomorrow if you have questions. So hope things are going well. And until tomorrow's video, we'll see you.